Aloha, Richard Halverson here. This is ITS148, and today is Tuesday, March 23rd, and we are about to do our 11th. I believe this is our 11th class video. So let me share my screen. And ITS148, and we are in. We finished chapter 15. Last week, or the last time we had class. Class number 10 video here is the two lab activities, showing you how I would do those, getting you started on those. And so we're going to start on chapter 16, lists, stacks, and queues. And these are actually more about the data structures themselves. Not so much Python. Of course, we're going to implement them in Python, but it's about learning about the data structures and how you manipulate the data structures, and when one data structure has an advantage over the other. And our assignments, there's no more. You'll notice in the Xi books, we're in chapter 16. There's no more green labs. So I'm taking this opportunity to have us. So I'm going to come up with five more assignments, and we're going to be doing them in Visual Studio. So you can either download. Don't download Visual Studio Code just yet. Okay, we're going to first try to do it with just plain old Visual Studio. So if you don't have Visual Studio installed on your computer, then go to visualstudio.microsoft.com and download and install the community editions of Visual Studio. And if you're on a Mac, you can wait, because I still have to do this for my Mac, and I want to make sure I can easily get Python on there. Visual Studio community with Python is a fine integrated development environment, and I'll be showing you how to use those, how to do that, but I want to make sure it's compatible on the Mac. Now, Visual Studio on the Mac for C#, for example, or for other languages where there's a tool which it's called the visual. I can't remember what it's for making the screens, the forms and the screens and so on. And that is not available, to be able to make a form on the screen just by dragging and dropping components. That's not, last I checked, which maybe was actually a couple of years ago, that was not running yet, Visual Studio on the Mac. But I don't know if things have changed. Things are probably going to change again, because Mac is moving away from Intel microprocessors, and one of the reasons why it was so easy to make all this cross-platform stuff is because the microprocessors were the same, the instruction sets were the same. But anyway, so we'll get to that later on this week. I've scheduled another class for this week on Thursday, and so we'll get into it then. And I'll have the first assignment. I changed the due dates for these assignments to be later, because I haven't really come up with them yet. I want to see how these lectures go. This is the first time I've lectured out of this. I've lectured this material before, but this is the first time I've done it out of this textbook, and it's also the first time I've done it in Python. So so let's get started with that. All right, so there's this concept of an abstract data type, the list, and so we're going to start by talking about the list abstract data type, and it's sort of a general data type that's got certain properties, and then from the list abstract data type, we can design or code singly linked lists or doubly linked lists, and learn how to sort them and make queues and stacks and so on. And a list has certain properties that are different than an array. Now, here comes the confusion. In Python, what we know in Python as a list is really an array. With a list, with an array, the amount of time that it takes to access any item is the same amount of time. Like if you want to access the first item in the list, it takes exactly the same amount of time as it is to access the 100th item in the list and the 1 millionth item in the list. It takes the same amount of time. Random access memory, that's an array. A list is not that way. A list, it's the elements are linked, one by one, one after the other. So in a plain old singly linked list, it takes 1 unit of time to access the first element, but it probably takes like 1,000 units of time to access the 1,000th element and 1,000,000 units of time to access the 1,000,000th element, because you have to start with the first one and you don't know where the second one. You find out, you learn where the second one is from the first one. You have to go to the first one to learn where the second one is, and then you have to go to the second one to learn where the third one is, and so on. And so in some ways that's seems like, gee, why would anybody ever want to do that? But let's say you wanted to insert a new element between the 1 millionth and the 1 millionth and first element, and you wanted to insert one right after the 1 millionth element. And so all the elements after 1 million would have to get shifted down by 1, right? That's how it would have to be in an array. But in a list, you can just go find the 1,000,000th element and then disconnect, put in a new one, connect it up again, and there you are. So anyway, we're going to learn about these things, and but we're going to start with just this abstract data type and learn some of the terminology and some of the basic operations that you'll see with all that are common to all list data types. So a list is a common abstract data type. Let's see what happens when I present. I guess I can close this. A list is a common abstract data type for holding ordered data and having operations like you append a data item, you can remove a data item, you can search whether it lists whether a data item is in the list or not, or you can print it. So here we see we create a new, we have to create a new list or something that's going to turn in, the starting of a list where you can do these operations on. It doesn't have any elements in it when you first start out, but it's got a handle there for a list. And then you can append 55 onto the list, and then you append 88 onto the list, and then you append 66 onto the list. Then you can print it, and then you can remove 88, and you can print it again. And we see it here. We can see this real quickly. We've created a new list called ages, and then we added 55, added 88, added 66. Then we're going to print the thing, and we print it, and then we're going to pop out 88 just like that, and then we're going to print it again, and we get 66. So some common operations are, appending onto the list, which inserts a new data item onto the end of the list. We can there's a prepend function, and these have different names in different languages and different contexts. So let's just go with the terminology that this book uses. It's the easiest, and they all are words that kind of mean the same thing. So it's not a big deal when you move into another context. But I tell you, this list is a difference. I'm gonna just search on this between list, Python, list, and array. Difference between a list and an array in Python. Is there really a difference? All right, it has to do with what can be stored in it. All right, so they're just comparing this with Python. But anyway, keep in mind, in this context of a list, we're not talking about a Python list, okay? We're talking about this abstract data type list. And here's another method where you have a list and you identify a particular item in the list, and then you want to insert this other new item right after that item. And this one, of course, removes one. We saw here, this one searches for it and tells you which returns the item if it's found, and returns an okay. So this does not return the index of the item or the position of the item, it returns the actual item itself. So that presumes the item can be an object, and you're sort of identifying it in some way this way. This actually prints the list items in order. This can print it in reverse order. This sorts the list in ascending order. And this tells you if there's no items in the list, and this returns the number of items in the list. Okay, so here's singly linked lists. So a singly linked list is a data structure for implementing a list abstract data type where each node has data and a pointer to the next node. And so this concept of a pointer is kind of a, you know, when you first hear about it, you're not really quite sure what it is. It's a little bit like, do we know about databases yet? It's a little bit like a primary key in a database table. It's a way of identifying and getting at a particular entity, like a data, like a record or an object. It's an address, okay, and that's what the next is. And so when you actually implement a list abstract data type, you're still implementing it in a memory that has, you know, physical addresses, and so you can implement a singly linked list abstract data type on top of an array, and then the next pointers are actually indexes to other positions in the array. And we'll get to more of that when we start getting into these assignments that I'm going to talk about and that we're going to implement on Visual Studio. All right, so so this is an example where you have, this is the sort of the handle, that's my term, the handle of the list, and it has a pointer to the head of the list, and so and then it also has, you know, and then each node has a pointer to the next element of the list. Okay, so you can get to head, you know, head dot data would be this thing, and head dot data would be that value, and head dot next would be the value that would take you to the next data record, or the next item. Let's see how what this looks like. So we're defining a new list, and then we're going to append that data item onto it, and then the tail is, there's a pointer to the tail too, and then this points nowhere, and then we're going to add another one, and so we get another one, and this thing points to it, and now the tail points to that, and this points to nothing. So now for the next one, this is going to point to the next one. This is also going to point to the next one, and then the next field of the next one is going to point to null. Oh, here we're prepending. Yeah, so you saw how that goes. Anyway, so that's an illustration of how these functions work. Append, given a new node, the append operation for a singly linked list inserts a new node after the tails node. So here, and here's how we express this. Okay, so let's just see what this looks like when we run it. So we start with that. Okay, so to add a new node, the first thing you do is you check to see if the head, the head field of the list, this head field is null. If the head field is null, then that means it's not pointing at anything. It means the list is empty. So if the head field is null, then you can say the head field is equal to the new node, and that's how you refer to it, just by this new node here. And then you also set the tail equal to the new node. However, if this head field is not null, in fact, right now it's not null. Right now it's pointing to that, to this node right here. So in the next case, it will, if there's a new node that needs to be added, it's going to be added right here. And the first thing it's going to do is it's going to make this next field point to that new node. So it's the list, the tail of the next. So the tail of the next is going to now point to the new node. It was pointing to null. Now it's going to point to the new node. And then the list of tail is going to also point to the new node. So then this is going to, instead of pointing to here, it's going to point to the new one. And so that's how that works. Makes a new node, goes down here, does this one, attaches the tail onto the tail of the next onto that, and then attaches this tail onto pointing to that. Okay, so our assignment, our assignments are going to involve creating these lists, manipulating them, adding some elements to them, printing them out, and you'll see this is what you'll be doing. You'll be manipulating these pointers and these data fields and values and so on, just like this. And we'll see how this is all implemented in Python. In fact, let's skip ahead, see if we can see that. Python, okay, looks like it's coming up here. So let's just keep moving here on this. Okay, prepend. So this one shows, given a new node, the prepend function for a singly linked list inserts a new node before the list's head node. So so let's say in this case, so we start with this, and we're going to create a new node, and the first time it's going to be the same as up there because it's empty, and we're just going to add a new node onto it. Does that, and then the tail is going to point to the new node. And now the second time, when we do this node 17, it's going to create a node 17. And then it's probably good. What's the first thing it does? It makes the, all right, it's going to take the new node, and it's got to take the value that's inside head, which is pointing to that one. The new node has to point to this one now. See, let's, maybe I've got some, there's nobody here, right? Okay, good. So let me just take my time here. Open up the whiteboard, and let's see, maybe I won't use the whiteboard now. I might use it later when these things get more complicated. Okay, so so let's just watch this happen. There'll be a new node. It has to take this value and put it in the next field of the new node, and then it has to take then it has to set this value to the new node. And then what about the tail? Oh, the tail is already that. The tail doesn't need to change. The tail is still going to point to this one. So the new node is going to be inserted back in here, and the tail is still going to point to that one. So that's why we aren't doing anything with the tail once there's a node in there. So anyway, yeah, okay, we can see that. Here's the second one. So how's this going to do that? Point that to there, and then it's going to do, this one's going to point to that. It's going to push, is it going to push it over? Yeah, there we go. And then we're done. All right, so so this is a challenge activity which tests our knowledge of what we just learned. And so I guess let's try this out, see what, I'll do one of them here. All right, what am I supposed to do? Oh, execute this. Okay, it's a new list. I'm going to append 42 onto the end of the list. I'm going to append 67 onto the end of the list. I'm going to append 60 onto the end of the list. So I guess it's 42, comma, 67, comma, 60. Is that right? Yes, it is. All right. And now we're doing some prepending. So first we're going to prepend 55, and then we're going to, since the list is empty, it doesn't matter if we prepend or append. It's put 55 as the first node of the list. And then we're going to prepend, so that's going to put it in front of the 55. So we end up with 63, comma 55. All right. And here we're doing an append and a prepend. And prepend doesn't matter. This can be a prepend or an append. The final is going to be 95, comma 51, comma 69. I'm pretty sure. Anyway, you can do those. Well, this is an interesting quiz. Appending a node to a singly linked list. Okay. Anyway, yeah, we're picking up on this stuff pretty good. All right, what's next? Insert. Okay, so insert after. So now we're just learning about more complicated methods here. And in this one, we're going to probably say, you know, after some node, insert some new node. So here we're using the insert after function. We wouldn't have to use insert after since we're inserting after the head node. Looks like we wouldn't have to use the insert after the tail node. So this is like appending. Inserting after the head node is like prepending, and this is the new thing. We're actually inserting something in the middle. Okay, so let's take a peek at see what this looks like. Okay, that's just gonna okay, creates a node, hooks it up. And now it's gonna put it after the tail. So the 15 is gonna go after the tail, I suppose. See, there's this current node variable that's pretty important because that's how you get at all the, puts it afterwards, and then the next one puts it in between the 9 and the 15. So there's going to be a 4 in between the 9 and the 15. So it's going to put that one, that gets stored there. And then this next is going to get stored. New node is going to equal, this next is going to equal new node. And that's going to insert it right in between here. So this tests your understanding of this insert after, insert after, insert after, insert after. Singly linked lists after the insert after algorithm. List insert after. This is the list, this is the node, and this is this is the new node. You put it after this node, assigns new node's next pointer. So it's inserting. So before new node, before this is inserted. Okay, so here we are, right here. And we want to insert this Q node right in between there. Now to do that, this next field is going to have to point to this one because that's what's going to come after it. And then this next field is going to have to be broken. It's going to have to point to this one. And that's about it. So assigns new nodes. This is this one's next pointer equal to next pointer with current node next, this one here. Current node next, that's this value right here. That is currently pointing to L, and we want what's, so this thing points to L, and we want this one to point to L. So we want to take what's in here and store it in here. So I guess it's that one. All right. Insert after node 1, this one, and we want to insert a new node 6. So executes which statement? It makes current node next equals new node. Okay, current node next equals new node. That's not here. That's one of the things it does. The other thing it does is it makes tail point to new node. List tail. Yeah, I guess that's right. This one's going to execute because this tail next list new node next is going to equal null. What's current node next? Yes, that's right. Current node next is equal to null, and this can equal to null. I think it's this one. Oh, no node is not inserted. New node is not inserted in the middle of the list. No, it's not. Current node is this. Next is null. New node is inserted after the list tail node. So new node's next pointer points to nothing. Well, this is nothing. Current node next is nothing. Well, I don't know. Let's find out what the answer is. Is it this one? No, it's this one. And it says new node is inserted after the list's tail node. List of tail of next. You know, I was confused because this says list and this says num list. So in my mind, I was automatically excluding both of these two. I should put a feedback. Oh, well, anyway, so let's say this list really is num list. And we say num list of tail is pointing to yes, okay. List tail next. Instead of pointing to null, it's got to point to new. Okay. All right. Well, anyway, so it's a good thing they let you click around and you still get all the points. You just have to answer the correct one eventually, and you get all the points. All right. So this singly linked lists insert. Insert after, insert after, insert after, insert after, insert after. Okay. So you have a num list that looks like that. So you've got something like 55, 27, right? You start with that. And then after 55, you're going to insert a 10. Okay, so I'm going to insert comma 10. And then after 10, I'm going to insert an 81. So I'm 81. And after 81, I'm going to store a 31. Okay, 31. Oops, 31. And then after the 81, I'm going to store a 64. So I got to go back to after the 81. And I'm going to store 64. Is that right? Yes, it is. Okay. Okay, we have a new list, and then we're going to put in a 29. And then we're going to, after the tail node, we're going to put in a 19. All right, I guess so 19 is going to go here. And then after the tail node, we're going to put a 47. Is that it? Yeah. All right. So anyway, you can do those. Remove. Okay. So remove. We have to go in and unlink these things, and then connect them back up again. So in this case here, if we're going to remove and the order counts, because if you do it in the wrong order, then you might lose some information that you need to store in some other next field or something. So if we're to remove the 7 here, then the first thing we want to do is we want to take the we need to make sure that this next field gets stored into the head field, because instead of the head pointing to this one, we want the head to point to what this one points to. And this can stay the same. The tail can stay the same. So really all we're doing is we're taking the node that's pointed to by head, in this case, okay, so and then pointing and then storing this value into here. If we're going to get rid of the last one, we would simply, we would have a current node pointing to that. We would want this value to be stored in here. And since this value is pointing to the one that we're getting rid of, then how do we're going to have to, if we're getting rid of this node, we're going to have to somehow get to this node. We're going to have to somehow get to this node, because we want tail to point to this node, and we want to get to, and this has got to point to, we have to store a new value into here. Okay, so how do we do that? Let's see how we do this node removal. Okay, so I have something that looks like this. So we're going to remove after null. What does that do? Let's see. Given a specified existing node in a singly linked list, the remove after operation removes the node after the specified list node. The existing node must be specified because each node in a singly linked list only maintains a pointer to the next node. So the existing node is specified with the current node parameter. If the current node is null, the remove after removes the list's first node. Otherwise, the algorithm removes the node after the current node. So, all right, so I'm going to start this over again. How do I start this over again? Well, let's just keep moving here. Ah, I see. This means remove the first element in the list, because there's no element before the first element in the list. I got it. Now the next one here, we're going to remove the after list 4. So we got to go to list 4 IC. Yes, so we go to list 4, and now we know how to get to this one. And we got to take this next field and store it into here. This is the successor node. This is the current node, and we need to take the successor node. It's got to be stored into the next field because we're eliminating this node. So this one has got to point to this one. See? Now that one's gone. Now what happens when we remove the last one? Current node next is null. So the successor node is null. So this next field is going to be stored, null is going to be stored in the next. What about this thing? Yeah, so it checks if this is null, then it knows that the tail node is got to be put back to the current node. All right. So here's understanding the remove one, and so we're going to be writing these. We're going to be writing code to do these things, and then we're going to, give you some test code and see that works. I'm able to make my own labs in this. I pay extra to be able to make my own labs, and these are just Python programs. So maybe I'll try making a lab or two. Actually, I want to run it on. I want to see that you can run it on Visual Studio. So we'll see about that. All right. So remove after algorithm. So this is given a num list, remove after executes the following statements. Okay, let's say we're going to remove after 55. So the first thing we need to do is we need to make the successor node. We're moving the one after 55. So the successor node is the list head next. No, I think this is wrong. Okay, the current node of next is equal to the successor node. Oh yes, okay, so this is going to be the current node. Data 55 is going to be the current node, and we want the next field. And this, okay, so this is going to be the current node, and this is going to be the successor node, right? Anyway, yeah, let's see if I'm right. So it's true that the current node is going to equal. Is this true? Yes. Okay. Successor node. Okay. So the node 55 next pointer is going to point to 74. Okay. The list head is going to equal to no. This is the successor node. The list head is not going to equal to the successor node. The list tail is equal to the current node. No, the list tail is going to remain the same. All right, move value. This is for, we're going to remove the head node, so we're going to remove H. So the current node is null, I guess, and the successor node is this one. So the successor node is equal to the list head next. Yes, that's right. List head next is points to the successor node. This is the successor node. So is this true? Yes. The current node next is equal to the successor node. So the current node is null. Yes, current node. I don't think this is gonna, I don't think this is right. Current node is null, which does not point to a valid node. All right. Yeah, current node is null. List head points to the successor node. Yes, this is going to be true. And the list tail is going to be point to the current node. No, current node is null. Current node is null. All right. So here is a challenge activity on removing singly linked, removing nodes from a singly linked list. And I think you can probably do this yourself. I'll do one of them. Given the list that, what list results from the following operations? So I'm just going to start with that. Remove after node 3. So remove this one. Remove after null. So that means remove the first one. And remove after node 1. So that means remove the 8. So I'm going to take that space out of there, see what this does, and lo and behold, that's the right answer. All right. Searching is okay, searching. Good. So we'll at least get to Python singly linked lists today, and then you'll get the idea. And then we're going to go through doubly linked lists, which just means that there's a link going back, and so stuff changes. But it's easier to traverse through it and all that. And then there's also these special ones with special extra methods to implement a stack functions and queue functions, and there's another one to kind of also deep functions or whatever, DQ functions. And so so here's searching. Well, searching, of course, is it's just has to traverse until it finds. So given a key, a search algorithm returns the first node whose data matches the key, or returns null if it's not found. A simple linked list search checks the current node, returning that node if it's a match. Or pointing to the next node and repeating. If the pointer of the current node is null, then it returns null, which means it wasn't found. Okay, so we're searching for something, searching for 5. It's going to blah blah. This is painfully obvious. So it keeps on. Keeps on going until current node is either null or it exits out of here, which is not good code, but okay. So how many nodes will list search visit when searching for 54? So it's going to visit 1, 2, 3. I think the answer is 3. Let's just check. Yes. How many nodes will list search visit when searching for 48? Well, 1, 2, 3, 4, 5, 6. Or is it 7? I think it's just 6. Yeah, 6. What value does list search return if the search key is not found? Null, I guess. All right, searching list search. Okay, so assigns the current node equal to first assigns the current node equal to node M. All right, so anyway, Picard, Riker, and Kirk. Those names sound familiar. All right, so challenge activity, linked list search. List search points to the current pointer. Now let me just start this and see what happens. Okay. list search 8 points the current pointer 18 to after checking node 22. After checking node 22, the current pointer is going to be set pointing to 43. Oh. Node after checking node 22, I guess it should be 43. Is this 43? Is that right? List 18. Okay, so what we're searching for 18. 18 is all the way down here, but right after checking node 22, the current pointer I guess the current pointer is going to be 43. And then list search 18 will make how many comparisons? It'll be 1 comparison, 2 comparison, 3 comparisons, 4 comparisons. 4? I wonder what this is right. Oh, yeah. Okay. All right, so you understood my logic there, so you can do the next one. All right, now we're going to get into Python singly linked lists, and hopefully now we can learn enough to be able to start writing some code, although I'm not prepared to write code today. Shoot, I should have. Is there any code we can? Ooh, there is code. Well, let's see if I can do that. Let me start. Do I have Visual Studio on my computer, or did I get rid of it? Let me see. Visual Studio 2019. Okay, I'm just going to open up this Visual Studio. I'm going to start opening it up. It takes a long time. So let's go up here and look at Python. Okay, constructing the node and list class. In Python, classes are used for both the linked list and the node and the nodes that comprise the list. Okay. Each class includes references to nodes. Okay, next node for the node class and head and tail nodes for the linked list class. Does that make sense? It should. The node class implements a list node and 2 data members. Data value. Okay, so while I'm at it here, so this thing popped up. And see, I was fiddling around with some Python back in last year. All right, get started. Clone or repo, open a project or solution, create a new project. I'm going to create a new project. And I'm going to create a Python application. So when I installed this, I made sure I installed, there's a whole list of stuff you can, I'm going to do create a Python command line application. I guess that's okay. Later on, we can fool around with some of these other nice Python projects, but right now I'm just going to do this one. Do I press one of these? I'm going to do this. Well, I think they're all the same. Next. Python application 2. Okay, that's a fine name for it. I'm going to say Python application ITS148. And what's today is 2021-03-23. Place solution and project in the same directory. Create, I'll do the default. Okay, well, anyway, while this is being created, so a node class is just going to look like this, and this is what you'd expect. This is initialize that there's going to be a data field, and then there's going to be a next field, and this is going to be so this here it's going to create it, and so it's going to create a node called that, and the data field is going to be 95, and the next field is going to set to none. It's going to be set to none. And for the, so this is a node, and a linked list is just going to have a head and a tail. And these heads and tails are going to have to point to nodes. And this is going to have to point to a node, and this is going to have to point to a node, and this is going to have to point to a node. So we're going to have to be able to get to the next node with this. Okay, here's how you start it up. Okay, so so when Visual Studio Python finally opens up for me, it looks like this. And so I wonder what I can do. How about if I do print hello world? That. How do I run it? Start. Oh, this thing pops up. Oh, and it says hello world. What do you know? Ran. That's nice. Okay, well, anyway, we'll get back to that Thursday. The node class has 2 data members. That's a trick question. Did I do these already? I'm going to say it's true. Node class has a member for node's data and member for the next node in the list. Okay, this is a trick question. The data value of a node is set to none if the node is not. No, the data value of a node is, doesn't know. An empty linked list has a single node with a data. This is just nonsense. Forget it. Appending a node to a singly linked list. Okay, so append method is a method within linked lists. Okay, so here, so append. So if we're appending onto a list, and so we access the list through this head and tail, and it's a list, and we check to see, first of all, if the head is set to none. If the head is set to none, that means the list is empty. So it's just going to you just hook the head onto the new node, and you hook the tail onto the new node. This is the new node right here. And otherwise, we're appending. So that means it's got to go onto the tail. So we need to go to the tail, go to the node that's at the tail, and the next field of the node that's at the tail, the next field of that node, it's set to null currently. It's got to be set to the new node. And then this tail of this list has got to be also set to the new node. All right, so that's what that is. That's how that method works. An appended node becomes the tail of a linked list. Yes. Which statements append a node with the data value 15 onto num list? Not that one, because you don't have that. You don't put that in the as an argument. This one looks good. Num list 15 append. This one, no. Node 8, no. Oh, maybe it's this one. How does that append work? Ah, it looks like this. It's a method dot method. So it's not that one, it must be this one. Okay. Singly linked additional methods. This is a prepend. And so that's where you put it in the beginning. So of course, if it's empty, if the list is empty, you do that, just stick it on there. If it's not empty, then there's going to be a new head of the list. So this new node, the next field of the new node has got to equal to the current, what the current head node is, and then so the next link of the new node is set up correctly, and then we're going to set a new head of this list to the new node. And then here's insert after, and here's remove after. All right, so here's some code, and here's the node code, the node class. Here's the linked list class, and this is just some code to try it out, prints it out. I wonder if I can. All right, I'm going to go out on a limb here. Okay, first of all, I'm going to run this and see what it looks like. That looks good. I'm going to see if I can run it in this here, right here. So how would I do that now? I tell you what, I'm not going to do this now because I think my Visual Studio is not set up right. I think I got the windows mixed up here because I set it up when I was teaching the assembly language course. They have you set up the Visual Studio differently. Okay, so I tell you what, this is a good place to stop. We are learning about Python code to manipulate and to implement a singly linked list. So on Thursday, I'm going to start by opening up. I'm going to start by talking about installing Python because I'm going to delete my Visual Studio and reinstall it, so it's fresh in my mind how to install it. I'm going to install it on the Mac also, and then we'll start by running this code in Visual Studio, and I'll have a nice little assignment for you. And this will be pretty good because then we should be able to breeze through doubly linked lists and go right to the Python doubly linked lists. Once you get the hang of that, there's just a backlink, and then some of these other ones also. So that's all I have for today. And if you have any questions after watching this, just send me an email, and I will see you I'll make my next video on Thursday. Thanks for watching.